Okay, so I have my chat window here. As was already mentioned, I will be kind of monitoring a little bit on the end. If I do see a question that is very relevant, I feel like I should take some time. I might actually stop and just answer that question. If I don't answer a question, it's probably just because I know that the answer is coming in a few slides, or I will just address it at the end. But feel free to put in anything in the chat, questions, comments, feedback, whatever you want. I'll be more than happy to try to answer these. So why don't I get started right away? And I will be spending a lot of time in my terminal, just because containers are kind of a CLI tool. So I figured, for this presentation, why not just, run everything from my terminal? So there you have it, containers for software developers. Ran out of space for my ASCII art there, but you have it there. So containers for software developers, this is what we're going to talk about today. Before I get started with our topic at hand, let me introduce myself. So hi, my name is Joel Lord. I am a developer advocate at Red Hat OpenShift. I'm currently based in Ottawa, lovely Ottawa, Canada. If you were in the room between the two talks, you probably heard me talk a little bit about me already. If you ever want to get in touch, Twitter is always the best way. I love Twitter. I'm always on Twitter. So my Twitter handle is kind of all over the place. You'll see it on my slides. So that's Joel with 2 underscores, Lord, Joel _ Lord. It's like the worst Twitter handle ever. But hey, it works. I'm also French Canadian, so you'll notice the accent sometimes. I just had a little glitch there. Seriously though, yeah, Twitter, always the best way to reach me. Feel free, any questions that you might have, just send them my way, whether it's on containers or OpenShift. Those are topics that I'm comfortable chatting, winter barbecuing, beer brewing, doesn't matter. Aha. Il y a quelqu'un d'autre qui est un francophone ici. Okay, so let's talk about containers. So why should you use containers? And that's the first question that I wanted to address. I know that you've probably all heard about the term container and you've heard about it, but really, why should you start using those? Well, really, it's all about having that same environment between production and your development environment. It's really about replicating that whole environment and making sure that you can reproduce everything inside all of those environments. And that's kind of the one thing that people will often talk about, having that same production environment all over the place. But it's also good for a bunch of different reasons. First of all, onboarding team members. It is great to onboard a new team member. So I don't know about you, but I've been doing some consultancy back in the days, or a few years ago, and I was an engineering manager, and whenever I had a team that was running it a little bit late or having struggles just to meet their deadline, I would just jump into the project. But sometimes I would have to, set up my whole environment, and they were using, Python 3, but I had the Python 2 runtimes installed on my machine, or they were using, PHP and Apache, but I didn't have any of that installed on my machine. So just getting everything ready, it takes a lot of time. So having containers can make it really easy, and you're going to see why, to just onboard, to onboard a new team member. So great for that. It's also great for open source contributions. And that is one of the things that really convinced me that containers were the way to go. So once I was using a project, and there was this tiny little change that I wanted to introduce into that project. It was a PHP project, and I used to do PHP a lot. I've been doing JavaScript development now for more than 10 years, but back in the days, I was a PHP developer. And there was this tiny change, and I knew I could potentially just do that change myself. But the thing is, I would have had to clone the repository, install Apache, install the PHP runtimes, install a database, find some data to input into my database, do all of that just to do that small little contribution. That's a lot of trouble. So what I would have normally done is, just put in an issue in GitHub, right? That's what we do, because it's too much trouble to install all of that tooling. But that specific project had a whole containerized environment. I was able to use Docker Compose, which I'm going to introduce at the end of this presentation. And with a single command, immediately all that environment was there for me. I had all the runtimes available. I had a database that was ready to be used. I had some data inside that database. Everything was there and ready for me to use. So that really convinced me that containers were definitely a good tool that I should use more in my day-to-day life. Of course, there's also testing. If you've ever done manual, or if you've ever had to deal with manual QA people, I've had to in the past. And I must admit, I am guilty of that. I got into some, well, disagreements with the QA team just because they had an issue. I couldn't reproduce it. And I just ended up tagging the issue in Jira as being non-reproducible. And then they just kept reopening it because it would happen all the time because they were running on a, PHP 7.1 or Node 12, and I was running on Node 14. So making sure that the environment is the same for everybody in your team really is important. And that's one of the key features of using containers. All right, it helps you with a lot of things. It won't solve all of your problems. It won't help you with the networking, DNS routing, everything that has to do with networking with your microservices and containers. That can still get a little bit tricky. And same thing with scaling. It kind of is a good step in the right direction, but it won't solve all of your scalability problems by itself. So in order to help you with networking and scaling, you will need another tool to orchestrate those containers, such as Kubernetes. And there's a talk about Kubernetes right after this talk. So, just stay in this track and you'll have all the good information about Kubernetes. Okay, so what is a container exactly? Well, a container is a standard unit of software that packages up code and all of its dependencies so the application runs quickly and reliably from one computing environment to another. So really, it's all about packaging up everything and making sure that the whole environment now is shipped with your application so that it makes it more reliable and more reproducible. It's a lightweight standalone executable package of software that includes everything needed to run an application. So code, runtime, system tools, system libraries, and settings. So basically, you can imagine a container being one big executable zip file that has not only your source code. So, and I'll show examples of PHP and Node.js because those are languages that I'm familiar with, but it applies for any language, right? But imagine not only shipping your JavaScript files, but also shipping, the Node.js runtime and all the configuration that is needed to run those files. So making sure that you ship everything as a whole and not just your source code. It's also a disposable unit. So once it's completed, it destroys itself along with all other dependencies. And that's very important. If you're going to use it for testing, especially, that is a really key thing to keep in mind. If you start inputting, or if you have some automated tests that will put in some information in your database, once you destroy your containers, once you take them down, all of that garbage that you've inputted in there is destroyed. It all disappeared. And the next time you start your testing, you start everything from fresh. So very good benefit in making sure that it's more reproducible every time. All right, so you might think it's just like a VM. Well, nope, it's not. So it is very similar in the sense of the end result. But if you have VMs, and without going into all of the details, but basically you have all of your infrastructure, so a laptop or a server somewhere, you've got a host operating system, and then you've got this thing called the hypervisor, which is in charge of distributing the resources and allocate the resources to a bunch of different VMs. So it'll take a part of your, of your RAM and then dedicate that to another VM. And then that VM will also have its own operating system with all of the applications running inside that VM. And you have the same for all of your resources. When you're dealing with containers, really, it's really part of the Linux operating system. If you're interested in understanding more about exactly how containers work, I have a link at the end for a great blog post by Larry Garfield called "The Container is a Lie," and it really explains why do we say that it's really part of the Linux operating system, and it has to do with resource allocation and so on. But how does it work? Essentially, as a software developer, for you, just the basics. You've got your infrastructure, you've got your host operating system, Linux. If it's not Linux, you will need some additional layer that would run a virtual machine. So if you have a Mac OS or a Windows machine, you would need Docker, which will start a Linux virtual machine. And then all of those containers are simply just processes inside of inside your Linux operating system. So it's blazing fast. You'll see some examples today. I'll start some containers and it just starts immediately. So it's really, really, really quick, and it has a better resource management because I don't need a full other operating system for each one of those containers. All right, I've talked about containers so far. Where does Docker fit into that? Well, I've just hinted a little bit at that. It is one of the tools to run containers on Windows or Mac OS. It's probably it's definitely the most popular tool. On Windows or Mac OS, it will create a virtual machine for you. If you're using Linux, you can also use Podman as an alternative. There it is. It works really, really well. It doesn't have that daemon, that's what I use right now. If you install Docker on Fedora, which is my operating system, it will actually install Podman, but it will just create an alias between Podman and Docker, so you can use them both. They have the exact same syntax. Okay, so containers in practice. So I figured, why don't I show you real, examples that I've had and use cases for containers. And yeah, that will give you a better feel of how you can use them to make your life as a software developer a little bit more productive, I guess, with containers. One of my first use cases for a container was when one of my friends came to me and he was like, hey, I'm running this PHP code. I have this weird issue. I just need another pair of eyes. Would you mind taking a look at it? And sure, I mean, I always love to help my friends, but I didn't have PHP or Apache installed. And, all of that setup, it just takes time. And I didn't want to run with all of those things. But I had heard about containers. So I figured, I can probably use that to help me and him at the moment. So what I did basically was to use Docker. So I've used the Docker command. And yes, I've built a terminal inside my slides that runs inside my terminal because I can, right? Also, it's an open source tool. So if you're interested in CLI slides, hit me up afterwards. Okay, so I decided to use Docker. So Docker run is the command to run a container. I want to run that in the background. So I'm going to start an Apache server. I'll run it in the background with -d. What I'll need is to mount some ports. I want to make sure that any incoming request on my local machine will be mapped into the port 80 inside my container, which is the port that runs Docker. So I'll map those ports. Also map some files. I've got some PHP files on my file system. And I want to mount that into the Apache folder to serve the files. So it's sample/php. Mount that to /var.html. So if you're familiar with Apache, that probably rings a bell. And what else do I need? I'll make sure I remove this afterwards. I'll give it a name, my PHP, and I'll start PHP 7.4. I'm a little bit behind with my PHP version here, but you get the point. All right, PHP 7.4 Apache. Let's give that a try, and that's it. It started. So when you saw that random string, that was my container ID, and my container was started already. So now if I do a curl localhost 8080, you can see that I'm pinging my PHP page here. Are you not convinced? Let me open up VS Code and let's just take a quick look at my sample. I know it's not on screen yet. All right, there it is. And you can see here that, well, that's my PHP file. And I could change that to say hello world and then just add a hashtag OS101. So if I do a curl localhost again, 8080, and you can see that it appeared. So it's there. I also had curl localhost 8080 name equals Joel, and I can use it's just PHP, so it works. Cool. How cool is that? Like immediately I'm able to run an Apache server with PHP. Let's just take a look at those, and I'll stop this server this PHP server, Docker stop, how did I call it? My PHP? I think that was it. And now if I try to PHP, no, I don't have PHP installed on my laptop. And if I try to curl localhost 8080 again, you can see that it just doesn't work. I've also realized that I have a bunch of containers running, and I'll just need to stop them, or else I'm going to run into issues later on today. Okay, so what did I do right there? That was a lot of information. That was really quick. So I've used Docker run, which is the command to start a container. And you have to give it an image name. So the most basic command that you can do, Docker run. And in my case, I've used PHP 7.4 Apache. So PHP is the name of the image. The version is 7.4, and then there's many variants that are available for different images. So in the case of PHP, they have an Apache variant, which includes an Apache server. But yeah, you won't necessarily find Apache everywhere. If you want to run anything, if you want to try Redis, if you want to try Kafka, if you want to run a MySQL database, you want to test out MongoDB, look for their base image on hub.docker.com. There's a huge collection of base images, and you can just take a look and look for official images. Why don't I bring it up actually? And let me open up a new tab. There it is, hub.docker.com. And yeah, and there it is. So you can find a bunch of different things. I said, let's take a look at MySQL. There's probably a base image for MySQL, depending on how you want to call it. And you have it here. So basically, it will give you all the information on how to use it, all the version numbers that are available, as well as all the variants and a lot of information about each image. Okay, so I've decided to use PHP 7.4 Apache. I've also mapped some ports. So I've told Docker, or Podman in my case, map the port 8080 on my local machine to the port 80 inside that container. So Apache runs on port 80 inside my container, but I need to map it, or to tell my computer to route the traffic into that container. So I've mounted it to the port 8080 on my local machine, which then maps to port 80 inside the container. I've also did the same thing with a folder on my machine. So I said, well, take my current working directory and then mount that into /var/www/html. And that basically tells my container to use my current working directory as /var/www/html. And as far as the container is concerned, it's my current working directory is that folder exactly. So that enables me to run the container, do the changes on my local machine. I don't need to do the change in the files inside the container. So you saw how I was able to change the source code on my local machine, and immediately the changes were reflected in the container. That's because it actually uses the exact same file system. Other useful flags that you could use, and that I actually used in that example, -d to run it in detached mode, or to run it in the background. If I would have not used a -d, you would have seen all the logs from Apache come out. --rm removes the container after it stops, so it cleans up. One of the things when you start playing around with containers is that you need to download it. So I cheated a little bit. I've used an image that I already had in my cache, so I didn't have to download the whole image, which makes it a little bit faster. But once you're done with your, and the thing is that it'll end up taking a lot of disk space. So using --rm removes the container once you're done. It cleans up a little bit and will help you to save some disk space. --name names your container. You don't need to use that. You saw that big random string that came out when I typed my docker run command. I could use that to address my container. When you have one or two just laying around, it works well. But when you want to start scripting, you'll need some name for your container. So I have an alias that runs on my machine, which just starts an Nginx container from the folder that I'm currently in. And then I have another command to stop that container. So I give it a name so I can reference it later on. So those are use cases for using a name for your containers. Right, so that's the full command that I've used. So Docker run -d to run it in the background, --rm to clean it afterwards, --name just to give it a name. So I was able to stop it using that name, -v to mount a volume, -p to map the ports, and then the name of the image. And there you go, you've got a PHP Apache server. Another thing that you can do is with a different PHP variant. I said I don't use PHP. That's not entirely true. Sometimes it's kind of a nice, easy to use scripting language. So I kind of like to just write little scripts using PHP. Bash is fine, but syntax can be a little bit tricky. So sometimes it's a little bit easier to use PHP. So what if I just wanted to execute a PHP script? Well, I can use Docker run again, but this time instead of using the Apache variant, I don't need a full-fledged web server. I just want the PHP executable, so I can just use the PHP 7.4 image. And then after the name of the image, I specify the command to run, or the command that my container will run inside of the container once it started. So in this case, just php/app/cli, which will simply start the PHP executable and apply it on the script that I have there. You can also specify a working directory if it makes it easier for you. That's just an example there. So what does that look like? Well, basically, you would have a Docker run again, and you would, let's try to mount some files, so samples/php. And I will mount that to /app, doesn't matter where. The :z, if you're curious, that's a security, it has to do with SE Linux. So PHP 7.4 is the executable that I'm going to use. And then I'm going to use the PHP command CLI tool to execute /app/cli-php. And that's just a small PHP script that just counts the number of files in the folder. So I can start that and it just outputs whatever that PHP script did output. Cool. So if you want to run a Node.js or Express server, it's very similar. Docker run -v, mount some files again, and map your ports, and just give it the base image, Node 14 in this case, and then the command to run once the container is started. So yeah, let's give that a try. Docker run. I'll mount /p/sample/node. I believe that's the right folder. I'll mount that to /app. I'll mount some ports. So 3000, or map some ports, 3000 to 3000, --rm, -d, -name, -name, my node, and node 14, and node /app. All right. So this is a folder that has an Express server in it, and now I can do curl localhost 3000, and it has hello world. Perfect. So you saw how really quick it was. Say I wanted to try this exact same command, but I want to try it with node 12 just to see if it's backward compatible instead. Well, I can change my version number to node 12, node /app, and it actually needs to download. I didn't have node 12, I'm realizing. So you'll see how long it takes to actually download an image. There's a little bug with my terminal inside my slide inside my terminal, where it just gives me the final output. So you don't see what's going on line by line. Normally, if you would use that inside your terminal, you would actually see each one of the layers of an image being downloaded. Let's just wait a few seconds. That'll be a good time for me to take a sip of water. All right, there it is. So normally you would see each one of those layers appear one after the other. But you saw how I was able to use those. It caused me an error because I already had a container running with that same name. So I'll just stop it, stop my node. And I think I'm close to giving up on my CLI slide thing. Okay, there it is. There it is. All right, all right. Okay, I'll just quit on that one. Forget that example, but it works. I actually have an example later on. Okay, so no more works on my machine. Works on my machine, fixes that issue. Now every environment is exactly the same, and that is one of the big benefits. So one of the things that you might not have noticed because it was just a little bit outside of, but when I ran that Apache script, there was an error message that came up, something about a file not found, and I had a similar issue. So I reached out to my friend. I was like, "Hey, I'm trying to run your PHP project, but I'm getting a weird error about a file not found." He was like, "Hey, do you have the file called ctemplog.php?" was like, really? Like a hard-coded path? Like now I have to, I don't even have a Windows machine, so that's where you will need environment variables. So environment variables are used exactly for that. It stores a variable that can be specific to your environment. So things that you would vary from, your development environment to someone else's development environment, to your testing environment, to your production environment. It could be used for file names, such as this one, ports. They're very typical use cases of port. Typically, you would, if you were building a Node.js application, you would run in production or in development on port 3000. But then you would deploy it on port 80 because you don't want users to type in, mydomain.com's port 3000. Base URL for your APIs. Chances are that it will change between your testing environment and your production environment. You're probably not testing with your real live API, right? So those are all things that would go inside a environment variable. How to use those? Just use a -e flag with Docker, and you can pass a key value pair. And and you'll be able to use environment variable. Thank you, Matthew. That is exactly the link. So for people who are not monitoring the chat, I had questions about the slide deck. It is available at cli-slides.com or the GitHub repo is in there as well. So accessing environment variables when you're writing PHP code, it looks a little bit like this. So just use the global variable $_env and the name of the environment variable in Node.js process.env, and then you have access to those variables. So let me just, and now I'll rely on some scripts that I have because I'm getting lazy here. Also, I've been getting some errors. So let's try this one. So Docker run, I've got my volume that I mount. I map my ports, remove, delete, detach mode, give it a name, and then node. And it's not what I wanted to copy. Okay, copy. There it is. Let's try this. Okay, Docker run. Docker run -e. So I specified an environment variable. So name equals Joel. I mounted my volume, and I've used a Node 14 base image. So if I was to change that environment variable to something else, so say I would change it to, why is it not copying? All right. There you go. So if I now change that environment variable to a world, and I run that same script again, it will eventually output hello world. Once again, I've used another different version of Node.js. So let me finally give up on this and script/node env. I'm still gonna get the same issue. It doesn't matter. Okay. I did a practice run before, I swear, but I've used different versions and I've updated everything just before. Okay, so there it is. So now let me run the first command just so that we have it inside the window. There you go. Okay, whew. Boy, this is hard. And then I'll run my second command. There it is. Okay, so you see that I've used the exact same command for both, with the difference being my environment variable here. So the output for my code was hello Joel and hello world. There's another tiny difference that I did here is that the first one I've used Node 14 and the second one I've used Node 8. And you can see that as far as the container is concerned, this one is using Node 8.17. This one is using Node 14.16. And if I do node -- version, well, it's a coincidence. I'm actually using the same one here. But I could have something completely different on my machine. It doesn't matter. So really one of the big benefits as well of containers is that you can actually switch from one version to the other. So say you need to migrate from Node 8 to Node 14, well, you can just use a different base image and immediately you'll be able to see what works and what doesn't. So you don't have to, move back and forth between versioning on your local system. Those can also be very useful to initialize your containers. So MySQL will use a bunch of different environment variables to specify how do you want to set up a database if you want to start one. So in this case, I can specify the root password, the user, the password for the user, and so on. Another cool thing about a lot of containers is that they'll also have a entry point folder. So in this case, for MySQL, it has a folder called docker entry point-initdb.d. And any SQL file or SH file in there will automatically be executed before the container starts. So that can be useful to seed a database, for example. So let's take a look at this. Let me start a MySQL server. And actually, I'm giving up on my slides. So let me start my MySQL server, and you can see here that I have a root, a user, password pass. So one thing that I can do now that I have my container running, and you can see that it's here on MySQL, I can actually do docker exec-it, which will run a command in interactive mode. I'll run that on my MySQL image, and the command that I will run is /bin/bash. So that will open up a bash session. I am now connected inside my container, and from here I can do any command. So if I do an ls, I can see the content of this container. I don't have MySQL installed on my machine once again, but it is installed inside that container. So I can use mysql-u root-p root dash, there's no database. So let's just log in here and do show databases. And I can interact with my MySQL server now. So let's close this. Let's stop this container. And I've mentioned that you can also specify an initialization file. Let's do that now. If I can actually manage to copy stuff. I don't know why it's not copying today. Let's just wait until this one stops. Almost there, perfect. And let's copy this command. As you can see here, I've added my init.sql file. So now I can start this container again. You saw how fast it was. I can just run that docker exec command once again. And in here, I can do mysql-u root-p root-database presentation, I think it is. And from here, I can do select star from table conferences. No, I should do I should do use database presentation. Well, I'll get it eventually databases. All right, well, you can see that I have a database that was added there. Why is it not getting use database presentation? I was probably not reading the error messages. Oh, of course. All right. Okay, there you go. So select star from conferences. And there it is. Okay, so perfect. So you see that I already have a database that is all seeded and everything is up there and it's all working. Cool. So what else can we do with containers? Hey, well, if you've ever had to deal with MySQL, you've probably found that the MySQL tool is kind of nice, but not ideal. It's hard. The syntax is hard. So why don't I start a PHP myadmin server? So I've just ran a command as I was talking to you, and I now have localhost 8888 root, and there you have it. So I have an Apache server, PHP installed, everything connected to my database. All my data is there. Come on, how cool is that, right? Let's try to use a mind blown. Yeah, there it is. Okay, so yeah, you can easily do all of that stuff and spin up those servers very, very quickly using containers. So there's also more than a CLI. At one point, you'll first of all, there's a lot of commands. You don't always want to use all of that command, but sometimes you'll also want to package up your own images. You'll want to package up an image not only that maps with your local file system, but an actual image that has all of your source code and that you can ship. So you'll want to use Docker files for that. So they let you build your own images and share them. I've waste way too much time on typos, so I'm running low on time. But basically, to write a Docker file, you take a base image and then you copy your source code in it. For PHP, that's all you need. You're good to go. That's a full image that will have included all of your source code inside of it. So now it won't be mounted in your file system. So if you do a change on your file system, it won't be reflected in the container, but you now have a container that can then be deployed on a server. For Node.js, it's very similar. So you start from a base image, Node 14, expose reports, copy your source code, change your working directory, run npm install. So you install all of those Node modules inside of that container. And then once the container is start, use the command npm start to start your Node.js server. I'll skip that for now. Okay, so Docker build is used to build your images. Docker build that with -t will give it a name as well. You'll probably want to name your container so you can find them later on. A Docker build is used to create full custom images that can then be shared on registries, and the image is then ready to be shared with your team or to be deployed on your server. To share on a public registry, you can use multiple registries. Docker Hub is a popular one. They have a free tier, so you can put in a bunch of images in there. Koi is an open source registry that you can install on your own infrastructure, and Google, Azure, IBM, they all have their own. So take a look, just use the one that is the closest to where you want to deploy your applications generally. To push your image, Docker push, the name of your image. So it uses syntax familiar for most software developers, pull to download an image from the registry. More useful commands, I've already shown most of them. So Docker PS to list the running containers, Docker PS-A to list all the containers, even those that are not running. If you're not using --rm, there'll be a lot of them. Docker stop to stop a container from running, Docker rm to remove a container, Docker tag to rename your containers. All right, so once you start using containers, it's all nice and in theory, but when you get started, it just never behaves the way you want it, right? So debugging, there's a few command that you can use to help you with that. Docker logs can be useful to see what's going on inside of your container. So just give it the name of the container if you've used the -- name flag. -f to see the logs in real time as well. Docker exec, that's what the command that I've used to log in or to open up a session inside my container, and -it to make it interactive. You can also copy files to your container and from your container. That can be useful. Say you want to check what's the configuration file that is currently being used on your inside of your container. For example, you want to download that file into your local machine. So name of the container, location of the file, and the destination for that file. The opposite to copy something to your container. All right, so Docker logs, Docker exec, Docker cp. If you have to run multiple containers, this is where Docker Compose will come into play. So Docker Compose is a great tool that can be used to run a collection of containers. So say you have a PHP project and a MySQL database, and they'll always run together. That is exactly what was used for that open source project that I was talking about at the beginning. So they had, they had a Docker file, or Docker Compose file. And then I was just able to use Docker Compose up, and it took care of spinning up all of my containers, downloading all the images, and just getting everything to work. It's beautiful to see that in action. So in this case, it's a YAML file. It just describes all of your services. So I've got a database service running MySQL, and then I've got a web service running my PHP image right here. Docker Compose up will start all of your servers. Docker Compose down will take them down. So should you use them? Well, for your day-to-day development, yes, definitely. For me, I didn't want to get started with containers initially because I thought it was just another tool that would get into my way and prevent me from being productive. And it turns out that it's completely the opposite. It can make you so much more productive. I have a bunch of different projects that I use on my machine. I've got a lot of containers running different things like Keycloak and MySQL and MongoDB. And I never had to deal with the installation and configuration of those tools. It just works. So day-to-day development, definitely use them. It makes your life so much easier. For testing, you saw how cool that can be. I can input as much junk as I want. I can then take down my container, start it again, and it starts completely as it was new. If you do want to persist your data, you'll have to find strategies. There are some that are available as well, but for your day-to-day, and it also makes sure that everybody's running that exact same environment, so everybody can reproduce the same things. And finally, for your open source projects, yes, please do so. It makes it so much more easy for potential contributors to be able to easily jump in and actually and contribute to your project. I've mentioned already how that project that I've used, which is joined in, I would have put in a GitHub issue because I didn't want to install all that stuff, but because they had that all that tooling, I was able to just run Docker Compose, change the files, and then send my PR, and immediately everything was there. It's so much easier. As a matter of fact, if you do have an open source project and you need help containerizing your project, feel free to ping me on Twitter. I'll be more than happy to help you with that. I'll be more than happy to help you out. So Joel__Lord is my Twitter handle. You can reach me over there. If you want more information about containers, easy URL /containers. You'll find a few of the links there. And my Twitter handle is right there. So that is all I had. We've got about 4 minutes left, so I'll open it up for questions.
Thank you, Joel, for such an interesting talk, and people really like your slides and presentation. Maybe you want to learn more about that too. Let's see.
Thank you. Yeah, a lot of questions about the slide deck. So I'll put in the, I need my other keyboard here. Actually, let me do this here. No. Yep, got too many things open. I'll share the links for the slide deck, which is an open source project, of course. CLI-slides.com. It is built in Node.js. You could use it. You'll probably need Node installed on your machine to run it. Maybe not. I don't know. Anyways, take a look at it. You'll see. If you want my slides, guess what? Docker run -it Joel Lord /container slides, I believe is the command. That should start a container with my slide deck in it, because I can't do a PDF, so that's as good as it gets. I'm not sure if that's the exact command, but you'll find it on this URL here, actually easy URL 2/containers. /containers. There it is.
There are some questions in the Q&A, and I don't see anything in the chat. Let's see.
Oh, I forgot to use the Q&A.
The container is a good choice for high-level service application.
Okay, so there's a question. Why would I want to use Docker or Podman versus LXC? What are the pros and cons? And am I still taking advantage of containerization by using LXC? I have no clue what LXC is, to be honest. So I'll skip this question, and if I do have another minute, I'll get back to it. Great presentation, Joe. What did you use? CLI slides. Do you have experience running Docker in Python? I do not have examples of using Docker with Python, but basically it uses that exact same. So you just look for the base image. I've used it on a project. I just don't have an example handy. But I'm still sharing my screen. So you can check hub.docker.com. And that's actually the case for just about anything. So if you want to, use Redis for the first time, or if you want to use Kafka, or if you want to use Python inside of a container, well, in my case, Python, and then I can look for the official image. You should always check for the official image if you can. And here you have the version number, and there should be usage instructions. So how to build your Docker file, so you now know what a Docker file is, and how to run a single Python script. So you've got the exact command right there. So this is how you would use it. I know that someone just joined the call, so I'll just go quickly on. I'll take one more question. Container is a good choice for high-level service-based application. Is suitable for low-level internet. Okay, so concern about limited support on system D and low-level device access. this is a little bit more deeper than my current knowledge of containers. I know that systemd is tricky, but you can get it working inside of a container. I've managed to get it done for, I was trying to do something and it actually ended up working. So pretty much everything works, but I can't go into the details of how it works and exactly how, in the exact details of the architecture. Take a look at that link from Gary Garfield, which is linked in my use URL 2/containers page. And then you might find some information there that might be able to give you more information on that topic. All right, do I have the time to answer one or two more questions?
I think so. You have a couple of more minutes.
Okay. So does everyone on the team use the same Docker images? And if so, who decides what is the correct version? Yes. Ideally, everybody will use the same Docker images. Then you could keep that. One of the nice way that I've seen is either using a Docker Compose project, and then you can put that YAML file inside of your repo. Then everybody's using the exact same version. Who decides? Well, that's really up to how your team is organized, I guess. But you can definitely use a Docker Compose to make it easier to make sure everybody's using the same, or just have some some script files, and then make sure that everybody just runs that same file. And if somebody uploads it, then people will just reuse that same script, and they'll if you update the script in your Git repo, everybody will actually use the new image as well. And what does your usual development workflow looks like with containers? Make a change, build the image again, and test. Seems too time consuming. You are right. So typically you would only build the images to either deploy or to, depending on how your QA team is organized, maybe if you want to share an image with your QA team. So only build the image once you want to share that image. As far as your development team, they'll all be working, they'll be using a Docker image, but a little bit like I did with the first example, where I was able to, I ran that PHP server. So your container will manage all the runtimes, but it will actually map to your local file system. So you don't need to, rebuild that image every time. You just work directly from your local file system, everything works. And then you have a CI/CD pipeline that will produce an image at the end once you do a commit to your master repository or one of your branches, depending on how you're set up. All right, so that's all for your questions. Thank you so much for being here. And that is all I have. So thank you very much. Have a great day.